Okay, today we are doing mixed naming review as we start our week of review between Ionic and Covalent. So this is going to be pretty quick and all stuff that we've already learned. Also, forgive my voice. I've been fighting a cold, so anyway, let's keep going here. We've got Ionic and Covalent. When we start with Ionic, remember that Ionic has ions, and so we've got a cation, that's our positive side, and the anion, that's our negative side. And there are some different options when we're naming them. The cation, it can be regular. If it's regular, then use the element name on the periodic table. If it is polyatomic, use the list name. And if it is a transition metal, then put the element name with the charge in parentheses after it as a Roman numeral. And again, that is the charge. So Roman numerals till the charge, because there is no pattern for charge on the D block elements. And just to review, 1 is I, 2 is II, 3 III, 4 IV, 5 V, 6 VI, 7 VII, 8 VIII, 9 IX, and 10 X. So there's 1 through 10 in Roman numerals for cation side. For the anion, which is the second part of our compound, we've only got 2 options. We've got a regular nonmetal, which will use the element name and modified IDE ending. And if it's polyatomic, use the list name. So that's our Ionic naming. A couple other things about Ionic. When we're writing the formula from the name, we use the crisscross method. And remember that sometimes we have to unreduce to determine the Roman numeral for the charge. When we do the reverse crisscross method, sometimes we have to consider unreducing that charge so that the anion has the correct charge in the formula. So that is for ionic compounds. For covalent compounds, we don't have ions, so there is no crisscross method and charges. Instead, we are only focusing on what are called binary covalent compounds. So they have 2 elements, part of them. As we've already seen, some covalent compounds have 3, 4, 5 different nonmetals in them. We are focusing on just naming binary, 2-element covalent compounds. So the first element, you just use the element name with a prefix in front of it. So it's prefix plus the element name. And remember, the prefix is telling us how many of that element, but we don't use mono for the first element. For element 2, again, we do the prefix for how many, and then we have our element name modified. And for element 2, you can use all of the prefixes. These are really important to memorize, so if you don't have them memorized, make flashcards or find a Quizlet online or some other way that will help you remember them. Do some extra practice problems, but you really need to have these memorized. So 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 deca. And remember that modified is the IDE ending. I didn't finish that. So there's our recap for both of these, and then one note on covalent: if diatomic, just use the element name, not dioxide or dioxygen. O2 would be oxygen. For covalent compounds, we do not use the crisscross method. We just look at the prefix, match it up to how many, and use the periodic table to write the element names. Ionic is the only one that uses crisscross method, and covalent is the only one that uses prefixes. So we have some review naming for you to do on your own, and then some practice. So on the practice sheet, you'll do first determine if it's ionic or covalent through 1 through 10 in these blanks. And the best way to do that is to find out, is it metal and non-metal? That's ionic. Or is it all non-metals? That's covalent. So look at the elements. The only one that is kind of tricky are polyatomic ions. So when you see polyatomic ions, sometimes they look like they're all nonmetals, because they are. For example, if I had ammonium hydroxide, this looks like it's all nonmetals, but we know this is a cation and this is an anion. So this would be an example of kind of an exception where it's still ionic, because we know polyatomic ions work in the ionic system, and this would be ammonium hydroxide, even though it looks like it's all nonmetal. So that's an exception where we have to think, oh, these are polyatomic ions and this is still ionic, even though it has all nonmetals in it. Okay, so be on the lookout for that type of thing. So a couple of these we can do together. Sodium carbonate. We've got a metal and a polyatomic ion, that's ionic. So our name here, sodium carbonate. Okay, so the going from compound formula to name is pretty straightforward. Remember, it looks like we have a Roman numeral here, so you'll have to figure out the charge. This is an ionic. Whenever they're written here, I would suggest writing out the ions as well. So we've got iron and we've got sulfate. We know sulfate has to be -1. If you do reverse crisscross, remember that the 4 is not part of the crisscross, it's part of sulfate, and it would be 1 and 1. However, sulfate is always -2, so we have to unreduce. It's an example where we do that. And now we have iron 2 sulfate. Okay, a couple examples there. Going the other way, again, find ionic or covalent, and then write the name. So dinitrogen trioxide, this has prefixes, that's covalent. So we've got N2O3. Look at the prefixes and the element names and apply them appropriately. Vanadium 5 oxide. Write the ions, do the crisscross method. Okay, so there's ionic. Then our last practice for today is crazy chemical formulas, and you'll find a table full of chemical formulas. First, you'll label the compound as ionic or covalent in that first column. Then you'll notice that some are written incorrectly. Actually, most are written incorrectly. And if the formula is incorrect, fix it. And if it's correct, circle it. There are only 2 correct given formulas. So you will be correcting almost all of these. Try to figure out the 2 that are correct and fix the rest. So our first one's done for us, magnesium cyanide. And the mistake here is they did not put parentheses around the polyatomic ion. And so there's the correct formula. Ammonium fluoride, also ionic. Looks like they have the wrong charges on these guys when they did the crisscross method. So ammonium is +1 and fluorine is -1, making this just NH4F, not F2. It would be F2 if ammonium's charge was +2, but that is not the case. So I will let you continue working on these. Remember, crisscross method is only for ionic compounds and prefixes are only for covalent. And then tomorrow's work, you will be looking at different bond properties. And then I'll see you again on Wednesday to go over our Lewis structure differences, just to review. And I will make a video for that. Have a good week.